have seen some of the standard graphs. For example, we have seen constant functions. Then we have seen linear functions. Then we have seen quadratic functions. We have also seen square root functions. Apart from this, we have also seen some other functions such as exponential, logarithmic. Today we are going to go into more details of logarithmic functions, and after which we'll solve or we'll look for the remaining functions, which are piecewise functions, sigma functions, step function, triangular functions, etc. So good afternoon everyone. Let's start. So welcome to Atharva, Parth, Rutu, Khushi, Pranika, Aditya, Siona. Good afternoon everyone. Okay, so type in yes if you can see my green screen so that I can start. Is my voice audible to everyone? Okay,
Yes, sir.
Perfect. So Atharva, yeah. So here you go. First question, you have to find the value of x. So the question is solve. If question is solve, it means you have to find value of x or the unknown variable. If the question is simplify, you have to solve until the last step, which can be easily simplified. So in simplify questions, you don't get the exact value of x or y. You get the simplified version. In solve, it means that you have to find the value of variable. So the question is given to you, log of 2 plus log of x plus 3 minus log of 3x minus 5. This value is equal to log of 3. So solve means you have to find value of x. So how can I do that? We have seen few formulas yesterday. Log a plus log b can be written as log of a into b. And log a minus log b can be written as log of a upon b. So I'll use those properties now. Log a plus log b, I can write that as log of a into b. And log of a minus log of b formula is log of a upon b. So the minus term, I can write that in denominator. So in denominator, I will have 3x minus 5. Which is equal to how much? Log of 3. Just compare. So log of this term is equal to log of 3. So this term and this term should be same. Therefore, I can say that 2x plus 3 divided by 3x minus 5 should be equal to 3. So just simplify this. Simplifying, I can get 2x plus 2 3 is 6. Take to other side. 9x minus of 15. 9x minus 2x, 7x. 15 plus 6, 21, which means x should be equal to 3. So pretty simple. Just you have to know the formulas, and the formula was this: log of a into b is equal to log a plus log b. And which is the other formula? Log of a upon b is equal to log a minus log of b. Okay. Let's see next question. This is question number 26 from your textbook. If value of log of So if these values are given, then you have to show that or prove that okay. So in my proof that I can see, I have to show x by y plus y by x is equal to 7. There is no log term present in my show that. So I need to get rid of my log terms. What is given to me? This is given to me that log of this is equal to half log x plus half log y. Okay. So I'll start with what is given to me. Log of x plus y by 3 is equal to half log x plus half log y. I can take half common, and inside the bracket I'll get log x plus log y. And what is log a plus log b? Log a plus log b is log of a into b. So what would be log x plus log y? That would be log of x into y. Therefore, I can say this term is equal to half into log of xy. Now we have also seen one property yesterday, which is log of this term. I can write as power of this term. So this would be log of xy raised to power half. Which is this property? Since I can say that log of a to the power b, remember this long jump, it can come in the beginning, and you can write this as b into log of a. Similarly, converse, if you have b into log of a, then this b can go to the power, and you can write this as log of a to the power b. So this is half into log of xy, so I can write half as power of x and y. Now log of this term is equal to log of this term, which means both of these terms should be same. Therefore, I can say that x plus y by 3 should be equal to xy raised to half. Now what is xy raised to half? That means under root of xy. Square on both sides. Squaring on both sides, I will get x plus y the whole square, that is x square plus 2xy plus y square upon 3. 3 square is 9, and take 9 to other side, so I'll get 9 of square root of xy is xy. Therefore, divide throughout by xy and take 2xy to other side. Taking 2xy to other side, I will get x square plus y square is equal to 9xy minus 2xy, that is 7xy. And now divide by xy throughout. Dividing by xy, I am going to get x by y plus y by x is equal to 7, which I had to prove. Okay, so let's go again. This was given to me, so I've written this over here. Taking half common, log x plus log y is inside the bracket, and log a plus log b formula is log of a into b. So log x plus log y is log of x into y. Okay, so this next step, this half can be written as power of xy. Why? Because I have a formula. Log of a to the power b can be written as b into log of a. So long jump, it can come in starting. Similarly, vice versa. If I have b into log of a, I can write that as log of a to the power b. Then I have simplified this. Xy raised to half. Raised to half means square root. Log of this term and log of this term are equal, so both of these terms should be same. In my proof that I don't have square root anywhere, so I'm taking squares on both sides. Taking squares, I've just simplified this, and I get what I had to prove. Okay, so you have 30 seconds, copy this down. If you have any doubts, ask. If you have understood, type in yes. Okay, good afternoon. Good afternoon. Yes. Okay. So type in yes in the chat box if you have understood this. Okay, yes by Rishikesh, Parth, Payal, Om. Good. Pratibha is also saying understood. I'll give you 30 seconds if you want to copy this down or take a screenshot. Do solve along with me at home. Take a textbook and notes, pen, paper, and sit down. So that when you are writing with your own hands, you'll understand in a better way. You'll understand where you are getting stuck. So then you can ask that doubt. So just don't sit in front of screen and watch it like a movie. So understood from Parth, Payal, Melvin. Perfect. So I'll move to next questions then. Here we go. So this is question number 27. If log of x minus y upon 4 is equal to log of root x plus log of root y. Then I have to show that x plus y the whole square is equal to 20xy. Okay, so what is given to me? Log terms are given, and I have to show that x plus y the whole square is equal to 20xy. So this looks like a previous question, so we'll simplify accordingly. Our solution: log of x minus y upon 4 is equal to log of root x plus log of root y. So that means log of a plus log of b, which is equal to log of a into b. So that is log of root x into log of root y. So I can say that is also equal to log of under root of xy. Now log of this term is equal to log of this term. So both these terms should also be same. Therefore I can say that x minus y upon 4 is equal to under root of xy. And then square on both sides. Squaring on both sides, comma, we get comma x minus y the whole square. So x minus y the whole square is x square minus 2xy plus y square upon 4 square. 4 square is 16, and I'll shift 16 to this side. Under root of xy square is x into y. Okay, so now in my show that what I have over here is x plus y the whole square, not x minus y the whole square. So I need to get x plus y the whole square. And what is expansion of x plus y the whole square? X plus y the whole square is x square plus 2xy plus y square. So instead of having minus 2xy, I want plus 2xy. So how can I get plus 2xy? I will add 4xy. Another way you can think of this is, on your right hand side you are having 16xy. In your show that you want 20xy. So 4xy is less. So what you are going to do? You are going to add 4xy on both sides. So if you're adding 4xy on both sides, this term will be x square plus 4xy minus 2xy, that's plus 2xy plus y square, and 16 plus 4xy, that is 20xy. And in your last step, then you can add this. What is this? This is your x plus y the whole square, which is equal to 20 into x into y. Okay, let's see one more question. If x is given as log of bc to the base a, y is given as log of ca to the base b, z is given as log of ab to the base c, then I have to prove that 1 upon 1 plus x, 1 upon 1 plus y, plus 1 upon 1 plus z is equal to 1. Okay. So again, in my prove that I cannot see any log terms, so I will need to get rid of all my log terms. However, I don't have any starting point. All three values are given to me of x, y, and z. So what I will do in this particular question is, I will take all these x, y, z values and I will substitute them in my left hand side. So I'll start with my left hand side. Left hand side is 1 upon 1 plus x. But x value is given to me. What is value of x? X is equal to log of bc to the base a plus 1 upon 1 plus y. What is y value? Log of ca to the base b plus 1 upon 1 plus z. Z value is also given. Z is log of ab to the base c. We have seen one formula which is change of base. What is change of base formula? Change of base formula is if I have log of m to the base n, I can write that as log m upon log n. Okay, what is that formula? We'll see once again. If I'm having log of bc to the base a, I can write that as log of bc upon log of a. Log of m to the base n is log m upon log n. Therefore, log of bc to the base a would be log of bc upon log of a plus 1 upon 1 plus. So what would this be? Log of ca to the base b. So this would be log of ca upon log of b plus 1 upon, similarly this term, 1 plus log of ab upon log of c. Just simplify this over here. I will take log a LCM, so this would be log a plus log of bc, the whole term upon denominator, which is log of a. Similarly over here, take log b as your LCM, so this would be log b plus log of ca. What I'm doing in this step, I'm just taking LCM, nothing fancy. So in this step, log c is my LCM, so this is log c plus log of ab. The term which is present in denominator's denominator can be written into numerator according to laws of indices. So I can write this log a into numerator. So this would be log of a divided by log a plus log bc, applying formula log of a plus log b, log of a into b. So log a plus log bc can be written as log of a into bc, that is log abc. Similarly, log b I can write in numerator, log b plus log ca, log a into log b, log a plus log b is log of a into b. So log b plus log ca is also log of abc, b into ca, that is abc. Similarly, this term would be log c upon log of abc. Now, this is your LCM. In your LCM, you can see log of abc. And what is in your numerators part? Log a plus log b plus log c. And what is log a plus log b plus log c? That is also log of abc. Cancelling out, your answer is 1. Hence proved. So the 28th question I'll repeat once again. X, Y, and Z values were given to you. So you have just substituted these values over here. Then in this step, you have used your change of base formula. Log of BC to the base A is log of BC upon log of A. Similarly, for over here, you have used change of base formula. In your next step, you have taken LCM of log of A. Simple LCM, log A plus log BC. Similarly, over here, you have taken LCM, and over here, you have taken LCM. In the next step, the term which is present in denominator's denominator can be written in numerator. So this log A can be written in numerator. And the denominator terms would be log A plus log BC. Again, apply a logarithmic formula. Log A plus log B is log of A into B. So log A plus log BC is log of ABC. Similarly, for the rest of the two terms. Then take log of ABC as your LCM. In numerator, we'll have log A plus log B plus log C. And what is log A plus log B plus log C? Log of ABC. So cancel numerator denominator, you'll get answer as 1. Okay, so go through this, note down, you have 30 seconds. If you have any doubts, ask. Any particular step you have not understood, ask. 27th and 28th question. If you have understood everything, type in yes. Okay, yes from Parth. Last step of example 27. Okay, so in this last step of 27th, what we have done, I hope that you got till this point.
No, sir, it's actually 28. I by mistakenly typing it as 27.
Okay. So in this last step, what we'll do, I have not written one step actually because of lack of space. So I'll write next step over here. If you take your LCM of log ABC, in numerator you have log A plus log B plus log C. And what is log A plus log B plus log C? I can write that as log of A into B into C. And this is what I'm talking about, that this and this term will cancel out to give you 1. Okay, so does this answer your doubt?
Yes, sir.
Okay, perfect. Others? Type in if you have any doubts or questions, queries. Okay, understood from Om, Kashish, Pratibha. Perfect. I'll give you more 30 seconds to go through the question. Understand which formulas we have used. Okay, so let's move to next slide then. Next, we'll see what are piecewise defined functions. So first one is signum function. I'll draw the graph so that it is very clear. If value is 0 of x, value of y is also 0. However, if value of x is greater than 0, then value of y is always 1. So all the positive values of x, you are going to get y value as 1. And if value of x is any negative number, then value of y is -1. So how does this graph look? At point 0, if x is equal to 0, value of y is 0. But if x is greater than 0, value of y is equal to 1. And if x is less than 0, value of y is -1. Therefore, I can say that if x greater than 0, y value is equal to how much? 1. If x is equal to 0, y is also 0. But if x is less than 0, y is equal to 1. Now, what is domain and range of this? Domain means which are the values that you can put in, or your x values, as we have seen in our first lecture. So which values of x can you find out from here, or which values of x can you use? You can use any value of x. You can use 0 or any positive number of x or any negative value. So all the this is what your real axis of x and y. So all the real numbers is your domain. So you can write real numbers, or you can say from -infinity to +infinity. And what would be the range? So range in this particular case is only 3 numbers. You can get your answer as either 0 or 1 or -1. So which bracket you're using over here? You're using curly brackets, which are used in a set. So only 3 elements are present in this set: 0, 1 and -1. So this is signum function. Next is mod functions. Mod function is also known as absolute value functions. Now everyone is familiar with mod functions. In a school, we have seen some questions where if there was mod of 3, then we wrote mod of 3 as 3. And if there was mod of minus 5, we wrote value or answer of mod of minus 5 as 5. So what mod function basically did was it eliminated the minus sign. But why does mod function eliminate minus sign? What is meaning of mod? So mod function is your absolute value, which means distance from origin. So if I say 2 is at what distance from origin? 2 would be at a distance of 2 units from origin. Minus 5 point would be at what distance from origin? Minus 5 would be at a distance of 5 units from origin. As distance cannot be negative, so mod function is actually distance or your absolute value from origin. Therefore mod is always positive. So mod doesn't eliminate negative sign. Mod is actually absolute value from origin, which is always going to be positive. So you can say that if value of x is 0, value of y is also 0. If value of x is 1, value of y is also 1. If value of x is 2, value of y is also 2. So if I draw a graph, I'll get somewhat like this. But what about minus? Can I find value of mod of minus 1? Yes. What is mod of minus 1? Mod of minus 1 is 1. What is mod of minus 2? Mod of minus 2 is 2. And this will go on continue this side also. How do we write mod? We write mod in this way. 2 dash on sides and in between your letter or your variable, you can say x. So your function f of x is equal to mod of x. Now if you are writing your function f of x, what can be your possible values? Your possible values can be 0, or you can say these values would be greater than 0, or you can say these values would be not less than 0, because the values are always greater than 0. So when is the value 0? When x is equal to 0. When is the value of function positive? When x is greater than 0. So I am going to say my function is always positive. However, my function is always positive even if values of x are negative. What is value of minus 2? Mod of minus 2 is again 2. Therefore, even for x less than 0, my answer is what? It is positive. Okay, so just go through both of them and tell me what would be domain and range. So domain means your x values. Which x values can you put? You can write any value. So domain is all your real numbers. And range means which are the possible outcomes, or which is value of y, or the values of function in this particular case. So which values can you get? You can either get 0 or you can get positive. There is nothing in negative side. Therefore, you can say that your answer is from 0 to infinity. And which bracket should I use? Square bracket or round bracket? Is 0 answer included? Yes. So if 0 answer is included, I will use square bracket. So for square root function, I'm using square bracket 0 to infinity. For mod function, I'm using square bracket 0 to infinity. However, for my exponential functions, I had used round bracket for range from 0 to infinity, because for exponential functions, values are always going to be greater than 0. Value cannot be equal to 0. So go through these two. If you have any doubts, you can ask. You have 30 seconds. Copy this down. Type in yes if you have understood both the functions, signum and absolute value. Understood from Khushi, Asta and Parth. Perfect. So I'll move to next diagram then. Next one is GIF, that is greatest integer function, and that is also called as step function. Why is it called a step function? We'll see this. It is represented in square brackets. How is mod function represented? Mod function was represented in two straight lines, between two straight lines. To represent your GIF or step function, you are using square brackets. Okay. So before understanding the graph, I'll see few examples. So graph would be easy to understand. Now, what is a greatest integer function? If I'm having value of 5.2, what greatest integer function does is it rounds it off to the nearest integer which is less than that point. So I'm going to send 5.2 value into my machine. And which machine I'm having over here? This is my greatest integer function machine. And what this machine does is it takes this 5.2 value, it rounds it off to its closest number, which is less than this. Now, closest number which is, or closest integer which is near to this 5.2 is 5. So if I will put 5.2 in this machine, I will get 5 as my output. Consider one more example. If I put 3.1 in this machine, it will round it off and I will get output as 3. If I put 4.3, it will round it off and I will get my output as 4. Now remember that if there is 7.9, it will round it off to its closest integer which is less than this. So 7.9's closest integer which is less than 7.9, it is 7. Don't increase it. You have to find the closest integer which is less than this number. So 7.9's closest integer would be 7. Pi. What is value of pi? 3.14. Now if I round it up, what will I get? I will get 3. So what is my greatest integer function doing? It rounds it off to its closest natural number value. Now I want to find, suppose, value of this term, 0.2. What would be greatest integer function of 0.2? It would be 0. What is greatest integer function of 2? If I put in 2 directly, so it is already an integer, so you will get directly an integer output which is 2. So if you put 5 as your input, you'll directly get 5 as your output. Okay, but what about negative values? If I put minus 0.5, now which is closest integer to minus 0.5, which is less than minus 0.5? That is minus 1. So greatest integer function of minus 0.5 is minus 1. What would be greatest integer function of minus 1.5? It should be less than this. So less than minus 1.5 is minus 2. Remember that you are looking for negative numbers. So negative numbers keep on reducing on your left side. Now let's understand the graph. If my value of x is 0, what would be value of y? It would be 0. And it will remain 0 until which point? Until we reach first point or your value 1, because value of 0.5 would also be 0. So all the values of x between 0 to 1, I am always going to get my answer as 0. What would be greatest integer of 1? Greatest integer of 1 is directly going to jump over here. It is going to be 1. Then what would be greatest integer of 1.5? It would be 1. What is greatest integer of 1.9? It would be 1. So this will continue. For all the values of x between 1 and 2, I will get my greatest integer as 1. But when I reach at point 2, what would be greatest integer of 2? It is going to be 2. And this will continue till what point? Till my third. So what I'm having over here? I'm having holes over here, and I'm having dot or dark balls over here. And what do holes and dark balls mean? I've explained this in intervals in sets and relations. If I'm drawing holes, that means that point is not included. If I'm drawing a dark ball, it means that the point is included. As it is going in upper side, similarly, the diagram will go in this direction. So over here, you'll have this. So a hole over here, a dark ball over here, a hole over here, and a dark ball over here. So if you see this diagram, what does this look like? It looks like steps. Therefore, it is also called as a step function. From this diagram also, you can easily find out. If I say find greatest integer function of 2.5. So what is greatest integer function of 2.5? It is where? It is 2. Okay, so let's see one more. So the lecture is getting a bit delayed, but this is the last part, so I'll finish up this in 2 to 5 minutes. Fractional part is written in this way. F of x is equal to, in curly brackets, x. So for mod, how do we represent mod? Between two lines. How do we represent step function? Between square brackets. And how do we represent fractional part? We represent using curly brackets. Now, what does a fractional part or fractional function mean? If, again, we'll see a machine over here. If I am putting in value of 1.2, what my fractional function does is, it will ignore this part. It will just look at the decimal part. What is decimal part? 1.2, decimal part is 0.2. So it will just give me decimal output. I will get output as 0.2. So if I enter 5.3, what output I will get? I will get output as 0.3. It is going to ignore this. It is going to only focus on decimal portion. If I enter 7.2, what output I will get? I will just get 0.2. If I enter 10.9, what output I will get? I'll get output as 0.9. If I enter just 5, what output I'll get? 5 means you can write 5 as 5.0. So output I will get as 0. So what is the least value that can be present? Least value can be 0. And what is the maximum value that I can increase to? I can go up till 0.9999, because I cannot go above 1. Because if I increase this value, 5.0, I'll get answer as 0. 5.1, I'll get answer as 0.1. 5.5, answer is 0.5. 5.9, answer is 0.9. 5.999, answer is 0.999. But if I increase this further, 6, again what my answer will be? 6 can be written as 6.0. So again my answer will go to 0. So my lowest value is 0 and my highest value can be 0.99999, infinite number of 9s, but it cannot be 1, because when it will increment by 1, your counter will reset to 0. Okay, so how do we draw this diagram then? If value is 0, obviously you're going to get 0 as your answer. If value is 0.5, you'll also get your answer as 0.5, and it will increase till it reaches 1. At 1, the count will reset to 0. And again, 1.1 value will be 0.1, 1.9 value, it will again increase till 0.9. But at 2, it will again reset to 0. So your graph will somewhat look like this. So on the top portion, over here you're having holes, and the bottom portions you're having dark balls. And similarly, it will be on your negative side. For your negative side, if I am having minus 0.3, then your fractional value is 0.7, not 0.3. Therefore, if I continue on drawing my diagrams, it will look like this. Now let's find domain and range for this. Domain means what are the values of x that I can input in the machine. I can put in any value. I can put 3.14 or I can put minus 3.001. So domain is all the real numbers, or you can say all numbers from minus infinity to infinity. But what is my range? My range is from 0 to 1. Maximum value that I can get is 1. I cannot go above 1. Now which bracket should I use over here? Is 0 value possible? Yes. So 0 point is included. So I'll use square bracket. But value 1 is included? No, because my maximum value for fractional can be 0.99999. If it increases above that, counter resets to next point. So over here, I will have round bracket. And similarly, domain of this, you can put all your real numbers. So domain is all the real numbers, or minus infinity to infinity. And your range is, you can get 0 as your answer, 1 as your answer, 2 as your answer, minus 1 as your answer, or minus 2 as your answer. So what are these? These are your integers. So you can get any integer as your answer. Okay, so it was a bit heavy, but I hope this part was clear. Let me know in the chat box if you have understood this. Perfect. So author has already written 0 to 1. And we'll follow a regular drill. Type in the chat box to let me know if you have understood, got it, comments, replies. Thank you, got it. Understood from Parth, Kashish, Rushikesh, Kushi. Thank you. So tomorrow we'll meet in next lecture. Got it. Understand. Okay, perfect. Thank you, everyone. Understood well. From Om, Melvin. Perfect. Anika has got it. Thank you. Thank you.